this thing. Get it out of the way so it's not in my camera view. Hello, folks. Ladies, gentlemen, other. Anyway, I have got to take this off. Okay, there we go. That's way better. This is just them. There we go. All right, so this video goes out to a very special subscriber. This goes out to you, Timmy. Timmy! This one goes out for you, bud. Anyway, I've discussed using coaxial cable to run power. Now, you can do this, and it works very, very well for light-duty applications. Where I have done this in the past is at an RV park. I used it to feed PowerBox Pros. Here is the exact configuration of the PowerBox Pro. The PowerBox Pro had a 48 volt line feeding it through the DC port, and then there was a fiber SFP in it, a Ubiquiti 3-kilometer gigabit BiDi in the SFP cage, and then one single access point, which was a Unify Mesh Pro. So I used Coax. And why did I use Coax? Because the park staff know how to crimp coaxial cables. Now, these things are handy. Okay, so this is very, very handy for light current applications. I might do another video, maybe tonight, testing load and how much loss you see over this, because this is 18 gauge cable. Very, very light. Remember, light cable. This is 18 gauge. According to my calculations here, according to the NEC, 18 gauge is typically rated for about 9.5 amps peak. I wrote it down right there just in case I forgot, right? Now, I did some math here. I used one of those voltage drop calculators. And it's showing here that I used a 100-foot distance as an example, by the way. So we've got 18 gauge, 100 feet, DC 54.4, 5 amp load on this one. And we're losing 6 volts by the time that we get to the end. So that would put us at, what, 48 volts approximately, like on the nose, under load, 5 amps, right? So it's 11% drop. Now, I just realized something. I didn't put the 50 ohm in there. So you know what? If you want to go to the voltage drop calculator and do your own math, please do it. I encourage you to do it. Use your noggin. That's what Google's for. So anyway. Timmy! There we go. Let's move that out of the way. So here's what I've done. So typically, I'll take my braiding, and the braiding is actually what encapsulates the whole thing. So with RF, this is great because this is your ground plane. This is what's protecting and shielding. What's inside, the juicy bits, right? Now, what I like about this is that this also, since the whole cable is encapsulated in this shield, it's great for protecting the power, the positive feed on the inside here, from ESD, from a near lightning hit or whatever, right? So it's actually good to keep noise out of your cables and whatnot, right? So now, that being said, I'm going to nip off a little bit of this. Oh, I'm doing this backwards. Hold on. So usually what I'll do is I'll actually use the negative on the shield, and I will also connect the shield to earth. I will bond it to earth. Okay, and then that way that allows for any kind of discharge to make it back to earth. So usually I'll take like a power pack with this. I use those, you guys have seen these before, I'm sure. These little guys here. I'll put it up in front of the camera. There, these. Little terminal block on them. You guys have seen these. So you can buy these as sets. You get a female and a male with it. Oh, how dare I assume its identity. No, I'm just kidding. I can make that joke. Anyway, so the idea here is that you can put these on either end of it ultimately, but I also have usually a number 12 connected to the shield here, even though the shield is the equivalent of an 18 gauge anyway or less. I like to do that just to make sure that it drains. And honestly, 4 years running, nothing damaged, in a very, very high lightning zone, by the way. So I'd say that's probably working. So let's get down to the meat of it. This is a really easy application. You crimp the one end of the cable and you put on your UHF connector, okay? Whatever flavor you want. And then you just simply do this. It's not hard, guys. See, I'm going to expose this, the shielded core, here, like so. Now, I would like to peel back some of this foil. I wonder if I can actually do that. Let's see here. Is there a ledge or something? There it is. There's a little lip. Because I just want to make sure that it's not going to short. Didn't do that before, but let's see if I can actually do it now. No, it's fine though. Trust me, it's fine. So what I'm going to do here is, let's take it one step further maybe. There, that makes me feel just a tiny bit better. Timmy! Oh, you're gonna hate me for that, aren't you? Well, you pestered me. So I'm gonna totally troll you, you silly bugger. And I'm gonna have fun doing it. Alright, so I've got my heat shrink here. This is the heat shrink to go over the positive conductor on the inside. I need a slightly bigger one. Now these are typically, this is where I get my heat shrink from. Doesn't necessarily have to be red. So I'll put the reds back in here. I'm gonna grab a couple of little blacks here. Yay. Awesome. Alright. So I'm just gonna nip off a tiny bit. By the way, these are for trimming my cat's nails, and they ended up on my workbench because god damn, they just work so awesome for this. They really do. And the cool thing is that if you get a burr, just like that, beauty. They work perfectly for stripping small cables. Love it. So this is also 18 AWG. All right, so I'm gonna put a tiny bit of flux on here. Flux it, yeah, flux it. A little bit of flux around here. And now we're gonna just put a little bit of solder on here. My soldering skills are second to none. I like to say that, but where did my thing go? Well, that's no good. That did not work the way I was hoping it to. And trust me, I've done that a few hundred times. Wow, that's a quick burn. That's why, because my little tip's not on there. Ha! You just saw me burn myself. That's funny. Alright, so here we go. Let's get a little bit of solder on here. It stinks in here now. Alright. I love clowning around. Because I am a fool. There we go. See what I'm doing? This isn't rocket science, I'm telling you guys. It's not. It's just, and the reason why I chose the Coax, as I said, is because it's like, it's good for a light load. It's tough cable, like as far as like durability to the elements goes, but it's perfect for a light duty application like this. You know, by the way, I still haven't gotten a third hand. So you know what? If any of you guys actually appreciate the videos that I make and you really want to help me out with something, find me a good third hand. Because, you know, I'm just terrible. I mean, like, I feel embarrassed sometimes because I watch my mentors, like, you know, EEV blog or Big Clive or whatever, and they have these gorgeous third hands, and here's me, like a friggin' reptile. Just, not that there's any problems with reptiles. I have plenty of friends that are good friends that are reptiles, so there we go. We make sure that's nice and in line, by the way, because we don't want tension to knock that off. So you see, I've just soldered that on there. I've left a little bit of gap because there's this nice foil shield here. And so that one's done. So now I'm just going to take a little bit of glue-filled heat shrink. Slip that on there. God, it's so hard. I always struggle to get it in the hole. It's a real pain in the ass, and I've had a real problem with that forever. You just fumble around and you can't get it in, and finally it just slips in and goes on like it was nothing. Timmy! Timmy, Timmy! Alright, there's the first part done. I gotta heat this up enough that the glue starts squishing out the top and bottom. There, that part's done. Okay, so now I'm just gonna take my tweezers here, and I am going to, there we go. And I'll do a second one too, by the way, for you guys, because you know what? Why not? Everybody loves burning their fingers. I'm just gonna do that again. No, I'm not. Of course, you guys probably love to see me suffer. I know how horrible and god-awful you creepy primates are. Alright, there we go. I'm gonna get this guy here. Do-do-do-do-do. That hurts like shit. And that's going to bother me for the next week. Ugh. Alright, here we go. I'm going to clip this one off close so that it's below the signal. See there? I've got a bit of a gap there between the signal. Can I... See? Alright, so now that one's done. And now because this is a streamlined inline splice, I don't actually necessarily need to heat shrink that because this is all the same continuity. The shield is bonded to the jacket, right? So this is just going to go on here and the heat shrink's going to go right over top of it. Easy peasy, lemon squeezy, right? So I'm just going to nip off a little tiny bit of this, like so. I'm going to tin these, like so. Oh, my fucking fingers. Oh! You know, that one's, you know what? I deserve that wholeheartedly because, like, I was cheating and instead of getting up and actually going to get a Brillo pad to clean my tip with, I decided to grab it with my fingers, and which I've done millions of times. If I was wearing jeans, I could actually do it with my jeans, believe it or not. Let's see here. Sometimes it just doesn't like to stick. And that has to do with the coating that's on this wire. There we go. It's starting to stick now. I give it a tiny bit more flux. It's oxidation that does that, by the way. Or it could also be that this is a could be that the shield just can't be soldered. What is the material that they made the shield out of? It's usually tinned copper. So this is not awesome because usually it literally does just solder. So in this case here it doesn't. But I guess that's not a bad thing because at the same time this allows for me to have to compensate, to have to deal with this. So now if anybody else has the same problem, they're going to be like, oh, how do we do this? So I'm just going to stick these together like so. And I am going to twist them, locking the conductors together like so. There we go. And I'm just going to keep twisting until I've got a nice little twisted thing like so. Now that that's all twisted together, hopefully this will bind and I can get a little bit of flux on here. I really should clean my flux container out. It's really easy, by the way. You can just put it in the microwave and all the shit will just sink to the bottom. And it'll give you wonderful COPD or emphysema. Alright. Let's see now. This guy started. There we go. Soak it up, baby. Yeah, I have not had this problem before. But you know what's funny is it's kind of like Murphy's Law. Anytime you're doing a video, something stupid like this will happen. It's like, ow, I'm not going to absorb anything. It's like probably like aluminium cabling or something idiotic like that. Oh, there we go. So there's a nice coating of solder on there. We'll let it cool for a second and see if it sticks. Relief. That feels better. Okay. Yeah, that's on there. I'm giving it a little pull test, okay? Just pulling my wire here. Alright, so now that we know that is, it's not pretty, but it's in there good, I'm going to move my last piece of heat shrink. As you can see, there's really no overlap here, and of course they are isolated from each other, so that's perfect. And if you want to be an extra badass, let me show you something I like to do sometimes. I'm going to do it with a lighter, not my heat gun. I'm really notorious. People who come over and like do crafts at my place, they're like, fire. So like they'll be like, oh, what the fuck's going on here? Why are all your your glue sticks all like melted, right? And it's like, oh, it's because I do this. So I'm going to heat up the end of this glue stick, and I'm just going to seal off the tip of this, just the tip, with a little bit of hot glue. You can do that too. This isn't like one of those rule of thumb things. It's just I noticed that my heat shrink pulled back a tiny bit, exposing a tiny little bit of the core signal lead. And I just want to make sure that there is no way in hell. Overkill is sometimes awesome, especially when you're doing something janky, that these two meet with each other. So now that is sealed. Awesome sauce. All right, so I'm going to pull this heat shrink up over top, like so. I'm going to make sure that's at least an inch is over top of here, so I made sure that there's plenty. So you see it's almost the middle, about 2/3 is up here, about 1/3 is down here. We're going to just hit it with the heat gun. Burn my fingers again. Now, the last thing I'm going to do is I'm going to test this. Always, 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 always test anything you do like this. Make sure it's happy. Here's my first piece of heat shrink. One piece of heat shrink should be enough, but not going to lie. As somebody who likes to prepare for the worst, always, let's grab another piece of heat shrink. A nice piece of Thomas & Betts glue-filled heat shrink. There we go. Oh, that's not long enough. Shit. There we go. That's long enough. It's a good thing I went and picked up more of this stuff. Here we go. So I'm just going to slide this on over, like so. Boopity bop. And I'm going to have it overlap the lower half of this heat shrink. I'd love to get the tip off of this so I can actually have the wide open mouth over top of the wire. It will seal so much better. But I'm not going to pull it off with my fingers like I always do because I just burn my fingers. Oh, Sarah, you're so smart. You're such a genius. Says people who don't know me. You know, it's a daily driver for me to do idiotic things. There we go. Look at all the glue squeezing out of that. That is prime. That is gorgeous. Right? Isn't that nice? So I'm just going to let that cool for a minute. Burn this hand now. Oh, glue. Oh, bloody hell. I do this for you. Oh, my bloody fingies. Oh. Oh. Looks like I'm not having any playtime tonight. So let's do a second one, okay? Alright, so I'm going to get my heat shrink over top. First, the main heat shrink, like so. And then I'm going to slide this down. Or you know what I might do? I'm going to do something a little bit different. Because I have to do this anyway, right? Check this out. I'm going to take my tweezers, run along. It's been a while since I've had to do any of these. Because it was a very specific application that I did this for. And Timmy wanted me to redo the video. So here I am redoing the video for Timmy. There we go. And now we'll nip off just a tiny bit of this. Take it off right about there. Boop. And I'll just spin this part off here. Beauty. She's a Bobby Dazzler. Who's PMing me? Many people. Cell phone second. Okay, nothing important. Let's see here. Now I've got my second one here. So now let's do this again. So we've just done the first one. Now we're going to do the second one. All right, I'm going to do it backwards this time. I'm going to do the black first. So I'm just going to strip this off. I am going to, because now that we learned that this conductor here does not want to be soldered, I really hope that it's not aluminium. You know what? There is a way I can tell, I think. Because if it's tinned, let's take these magnets here. I don't know. Let's see here. So I'm just gonna like take this copper and I'm gonna like intermingle these guys together like so, and then I'm just gonna twist it. Because that'll like lock all the fibers together, right? I'm sure electricians out there are cringing. But like I said, this isn't something that I would recommend doing. It's not that there's really anything too wrong with it. It's just this is not great. It's a hack. This is, by definition, a workaround, a band-aid, or a hack. There's nothing too wrong with doing this for the application that I described, like running a light load, like, say, a couple of security cameras or a Wi-Fi access point or a remote switch of some sort. There's really not a lot of problem, but that's because like we're talking about loads that are under 50 watts. Okay, so you don't want to really put a lot of power on a link like this, right? So if you're planning to run a piece of coax up a tower like this and use it to run like an edge point 16 or an atomic switch, that's ludicrous. Okay, yes, I showed you the math earlier in the loss calculator, but anytime I hook up an up tower switch, by the way, like an edge point 16 or an Atomics or a power 16, I run a minimum of 12 AWG up, okay? And that's both conductors, red and black. 12 AWG goes up. And I always encourage you to run 54 volts if you're going up tower. Because if you go up tower at 24, you're going to have a lot of loss, and you're going to need to up gauge, okay? So that being said, let's go back to what we're doing here. Burn my fingies some more. Let's see here. I wanted to get the worst out of the way, by the way. It's kind of why I jumped and did it like this. There we go. Oh my god, a song just popped into my head. What was that? Our Lady Peace, One Man Army. What a weird song just to randomly pop into my head. There we go. Okay, that's awesome. We'll just let that cool for a sec. Now, I just see that there's a couple of little loose strands here. Rather than have them puncture the core foam, I'm just going to kind of tweak them off here. Just tease them out. There, that's beautiful. We'll give it a little tug. That's not going anywhere. That's nice and solid. All right, so now we can get the center conductor. Mr. Conductor. Hello, my name is Dr. Green Thumb. I'd like to tell you just where I'm from. Burnt thumb and finger. Okay, we've tinned that. The core is tinned. Now, let us do the positive conductor. You're a positive conductor. Bum 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 bum. Bum 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 bum. I'm going insane. Timmy! Here we go. Alright, we'll just get a little bit of stuff on here. I'm going to like goober this one right up this time. So it's got like a blob getting ready to hang off. And we shall... Here we go. That's nice. No, that is not nice, actually. Look at the gap there. That's way too much. So, just gonna... You know, it's been years that I haven't had a third hand, by the way. So it's not like this is something new. I'm just really, really ADHD. There we go. Makes it easier when you can rest your hand on a surface, right? So I want to make sure that the two conductors are literally resting across each other like that when the solder cures. You don't want them like that. You want them like that for the strength. It's almost like a molecular bond. All right, there we go. Oh, isopropyl alcohol. Oh, it feels so good on my burned flesh. All right, so now I've got another little piece of glue-filled heat shrink here. I'm going to slip this. Oh, wait. Nope, sorry. I'm going to put a little bit of goopy. I'm going to goober this up and not set my hands on fire. So I'm just going to take a little bit of this, and I'm going to heat up my hot glue. And now I'm going to, there we go, just put a little bit around here. There. Now when I slide the heat shrink over it, that'll make sure that it's right down in there. Now again, that's just an extra step. I'm just doing that because I am uber overkilly, overcautious, right? Because this already has heat glue inside of the heat shrink. So when I slip this over like so, right? The heat shrink will shrink and tighten, but then if I keep heating it, you'll see that the glue starts to ooze out the ends. Right? So you see how the glue is like oozing out of that? You see that? Right? All my fingers are all goopy. Alright. Alright, so that's good. That is solid. I like that one. That heat shrink on the center lead actually turned out way better this time. Of course it did, because it's the second time I did it. Alright, so we've got this one now. Now let's heat shrink this. There's the top. Alright, let me get the heat shrink for the second layer. I'm an adult now. Now again, this will be easier with a wider mouth on the rework tool here, the little hot air gun. Oh my god, I like just burped in my mouth, and I just came from a friend's place who made pulled pork, or brisket, beef brisket, sorry. Oh my god, it was so good. That burp was wonderful. I am fearful for my well-being. There we go. That is rock solid. And look at all that awesome extra goopy that's coming out. Just wonderful. Alright. That should help it cool off. Alright, so now we've got two of these. I'm going to turn off the soldering iron because I don't want to like burn my fingers anymore. Stupid Sarah. Right, let's put the solder away. I've only been soldering for like 30 years of my life, by the way. It's not like I'm new to this. Wait. No, I started soldering at the age of 6. I'm 42 this year. "36 years I've been soldering?" Yeah, I've been soldering for 36 bloody years. Can you believe that? Yes, my parents let me operate a soldering iron at the age of 6. That's how long I've been doing this shit. Alright, so there we go. So now we've got our two leads. Remember, this is your positive. This is your negative, which is also to be bonded to Earth. Okay? And then we just simply put them together like so. Now, because this is power, you want to make damn sure that when you're screwing these guys together, that little tiny bit of foam in there is clear of debris. Because you don't want a little bit of a short to show up in there, and then you're like, damn it, I gotta recrimp this again. But the nice thing about doing this for like the applications I specified is now if something gets broken or chewed on or whatever, you can just cut it off and put a UHF connector on it with a coupler. It's handy as hell, right? Okay, so now let's get the load tester. And let's get the multimeter. Rah, rah, rah. Okay. I've got 2 multimeters, by the way. There's one right here. But I want you guys to actually see what I'm doing. So, look at this. Alright, first of all, let's make sure that we don't have a short. And the easiest way to do that is to test continuity between the 2 conductors. Okay. And I will do my test at 54.4 volts, by the way, folks. All right, there we go. So first, let's do our continuity test. I'm going to grab a set of these guys here. I should have a set of alligator clips, or crocodile clips, as they say. The proper terminology. I do have a set in here. Where the hell are they? I've got like so many of these bloody things. I really need to go through my cables. There they are. Alright, so first things first, let's just check continuity. So I'm going to set this for continuity. I'm just going to... Awesome. So now, if this beeps, we know that there is a fault. Nope, it's clean. Now let's test positive. Positive's good. Awesome. Let's go to negative. Negative. Cool. Alright. So now let's do an electrical test. So I'm going to put this right here. I'm going to put Mr. Clive over here. And that's right. Check out Big Clive. I'm a nothing YouTuber with 3,000 subs. He's a bloody legend with close to 1 million now, actually. And his voice is so soothing. Oh my god. If I'm ever anxious and having a really hard time getting to sleep, I'll throw on one of his less exciting videos. And they're all such intelligent videos. And it's just, his voice is dreamy. There we go. I'm not fangirling. Although one day I hope to actually go and meet him in person, one of the tech meetups in Scotland there. Be pretty cool, I think. I'd love to actually buy him a drink. Also need to meet Andy. I'm filling dead air, by the way. But yeah, this is the man who I would say started it all as far as YouTubers go. Photonic induction. He's a legend too. Alright, so we've got our load tester set up right here. I'm going to put Andy back on the wall. Photon, please make more videos. Alright, and I need a power cable for this. So, where have I got one? You know what? I can probably... I know. Hold on. I got one on the floor here. Whoops, whoops-a-doodle. What does this take? It takes USB micro or... Ah, crap. All of my cables are USB-C. What kind of a horrible joke is this? Damn. I am so sorry about the delay, folks. What is that? Where's that cable go? Oh, there we go. That'll work. Yeah, I think this is 12 volts. Oh, 7.6 volts. This is the one that I was using for my old camera, my Alpha, which now has been repurposed for other things. Okay, so this is a volt/current meter. This is actually a load tester. If you guys have not seen this before, I pull this bad boy out on occasion. It's pretty damn cool. We're going to set my power supply up here for 54.4 volts. And let's see here. 54.4. 54.6, whatever, close enough. I can fine tune that down to 54.4 if we want. There we go. We'll hook a positive here. I'm going to open up my current, and I'm going to turn down the load on this because I don't want to just crank it right off the hop. So my my bench power supply does approximately 5 amps. So let's dial this up slowly. There we go, 5 amps. How's the cable feel? Alright, fine. Yeah. I knew there was something up with my bench power supply. How did I just get a shock like that? There's a ground reference on this, or a high voltage reference on my multimeter. Which, guess what, Amazon? That's lawsuit territory. I got that right off the earth there. That's not cool. Wow, that was like a 120 volt shock. Not cool. Yeah, guess what? I am definitely going to have to research that. I should have gotten zapped like that. Not cool at all. Alright, so let's, I'm going to investigate that after. I got a shock right off of that. That is not cool. So let's do this. I'm going to unplug this now and reset it. And I'm going to, one of my friends actually, slash colleagues actually, slash clients, loaned me this FLIR, which I needed for a ecological video I'm working on. And what'll be neat is I'm just going to use it to check and see if the cable is increasing. There we go. In temperature while it's under load. I'll put 4 amps through it though. Let's do this. Can we get this down? You know, I put a bigger heat sink on it. I'm sort of regretting it. So this thing, I guess, maxes out at how many watts? It doesn't like I think I need to be under 250. Okay, so this thing's booting. So we'll run it at 4, and that should be about, yeah, 200-ish watts. All right, here we go. So let's, we've got the cable here. There we go. I don't know if you guys could see that. Oh, shit, did I move my camera? Not cool. There. All right, so now let us turn up the current. I'll run it at 4. There's 4 amps. Let's see if this guy gains temperature. Oh, cool. Look at that. So when I touch it, it's recording the heat off my fingers. Yeah, no increase in temperature at all. Cool. All right. So that's good. Now I want to try one other test. So what I want to do is I want to actually take one of my coaxial spools here. I'm going to run it over 500 feet and show you guys what kind of loss we're going to get. So I'm just going to connect this into, you guys have seen these before, right? Big spools of coaxial cable. So here we go. I'm going to connect this one over here. There we go. Let's plug it in. All right, so this is a 500-foot spool of RG6 that I'm connecting this to, which I purchased from TDL Canada, located in Trenton, Ontario. All right, now let's turn up the current, and now watch how much this guy drops. Look at that. I'm not even running an amp, and we're down to 40 volts. That's not really that usable. Not at 500 feet. I'm going to dial that up a little. 48 volts, 0.37 amps. So at 500 feet, the most we could do is about 24 watts. Otherwise, 54 volts. we're down to 21 volts at 2 amps. That's a lot of loss. Let's do one more test. Let's do this on 200 feet of cable instead. Kind of neat that you guys get to see the cable loss, right? Which in hindsight, I should actually do that. I should actually bust out a box of cable and demonstrate cable loss, right? Our current loss, power loss over cable, whatever. Here we go. I'm just going to do 200 feet because my calculations were done on the 100 foot. So it'll be really, really, really good for you guys to see this. All right, here we go. Don't want the load tester to get hot. There we go. And now you see why I'm so anal about, you know, what kind of cabling you guys use for DC. There's an important factoid behind it, right? So I'm not going to do a second video on this. Screw it. I'm doing it all in this. There we go. So I'm on 200 feet. Let me dial up the current, the load. So there we go. 200 feet. We're down to 44.2. 44.2 volts at 1.5 amps. That's low. That's like a dead battery, basically. If we were to run it at 48 volts at 200 feet, so you can literally run, you can, with the amount of loss you get, an acceptable amount of loss, you can run 50 watts at 200 feet on a piece of coaxial cable. 50 watts from 54 volts down to 48 volts. Keep that in mind. So when I say that I ran PowerBox Pro with a SFP in it, a 3-kilometer SFP, and a Mesh Pro, I literally had the 48 volt power supplies from Amazon, the 2 amp 48 volt, running over no more than 50 feet of coaxial cable to run the PowerBox Pro. So in a pinch, this works really good for light duty applications like small switches, like I don't know, a modified nano switch or a PowerBox Pro or whatever. But it's not the end all be all, and it is a handy little trick for specific situations. Just remember that, running power on this. And by the way, I have seen this before, so if any of you guys get the brilliant idea to try to run 120 volts over one of these guys, do not do it, because you're creating a massive risk, a safety hazard actually, and a direct electrical code violation. If you run 120 volts AC over one of these guys to run a repeater site that's up on top of a hill, do not do that. That is dumb, because many, many reasons. The most obvious is, what happens if a critter goes and chews on the cable and gets right through it, right? And then a little kid goes and jumps on the fence and gets a shock. Well, you could hurt the kid. You could even start a field fire, because if there's a break in the cable and you're running that up a hill with 120 volts in it, oh, well, the loss won't be as much. Think about it. 1 amp at 120 volts, that's 100 watts I'm getting up there. Yeah, but if that cable faults, there's going to be enough current there, enough power, you know, kVA, that you could arc and create a fire. You could start a field fire. You could electrocute a kid. And what if a kid had a bad heart? Or, you know, an elderly person was up there hiking and they went to go hop over the fence and it's just bzzz. This is a 48 volt. It's a low voltage application. A lot of coaxial networks are up in the 80 to 90 volts range. That's a different thing entirely, because that's proper heavy duty coax. So I think I've said enough. There's your safety precautions and whatnot. And there you go. I hope that this was enlightening. This video was made for Timmy. I made this for you, bud, because you wanted to see this video so bad again. All right, so there you go. Using power over coax for old coaxial cables. And this is separate from the magic SFP stuff, guys. This is literally usurping a coaxial cable and repurposing it specifically for this. And trust me, the fall off it's a big curve. I mean, like, I could graph it, but why would I bother? There's calculators for that. So you guys saw the fall off on this already, at how much fall off there was. So, I mean, why bother? All right, there you go. I hope that was enlightening. And that was a grand total of 45 minutes. So, thanks, guys. Don't forget to like and subscribe. Join the Patreon if you want to help feed me or help me buy equipment for the channel. We'll catch you later.